Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, let's thank to Allah Subhanahu wa Ta'ala who has been giving us some mercies and blessings so that we can attend this meeting without any troubles at all. Secondly, may salawat and salam be Prophet Muhammad Sallallahu Alaihi Wasallam, who has guided us from the darkness to the lightness in the world. Now, let's introduce myself. Hello everyone, my name is Kamilia Nadifa Zahra. You can call me Nadifa. I'm studying at Maulana Malik Ibrahim Said Islamic University Malang in the Faculty of Science and Technology in the Department of Chemistry in the chemistry class of C. Now here I will explain about my summary. My summary is coagulation and flocculation. Coagulation is the addition of chemicals to destabilize the electrostatic process of non-settlable solids. Coagulant chemicals typically have a positive charge which binds to the negatively charged particles in water, neutralizing them and allowing them to come together to form small clumps of particles called microflow. In most cases, the chemical reaction occurs in a fraction of a second. So it's important the coagulant is dispersed quickly and evenly to encourage as many particle collisions as possible. Because this process relies on chemical reactions, several considerations must be met. Water temperature, for example. Colder water usually slows coagulation and flocculation reactions, which may require more time to achieve optimal floc formation. Extreme values of pH high or low will also interfere with the process. Coagulant effectiveness is highly dependent on pH. For some coagulants, alkalinity is a factor. Operators may need to raise out validity for coagulation to be effective when using iron or aluminum coagulants that can consume alkalinity and depress pH when they are adapted to low alkalinity waters. Turbidity is also important too. The lower the turbidity, the more difficult it to form proper flow. The most common coagulant chemically used is aluminum sulfate, commonly called alum. When added to water, alum forms jelly-like particles of aluminum hydroxide. The trivalent aluminum ions neutralize and attach to negatively charged particles in water, forming microflow. Alum works best in a pH range 5.5 to 7.5. Polyaluminum chloride and iron salts such as ferric chloride and ferric sulfate are also used. They operate over a wider pH range. Coagulant and flocculates are adapted to improve binding, build stronger, more settlable floc, and evade flocculation by increasing floc ice strength and or floc density. In addition, they help overcome the effect of low temperatures, adjust the amount of coagulant needed, and reduce the amount of sludge produced. Commonly used coagulant aids include cationic polymers. Polymers are defined as a synthetic compound with high molecular weight and composed of repeating chemical units or monomers. Polymers may be polyelectrolytes such as the water-soluble flocculants, water-insoluble ion exchange resins, or insoluble uncharged materials. Polymers are long chains of molecules that produce highly charged ions and held by microflux together into larger particles. They are very popular with operators because they are very effective and can be positive, negative, or neutrally charged, providing a great deal of flexibility in different circumstances. Thank you. I would like to finish up by saying thank you for your time and your attention. I would like to thank you all for taking time to listen to my presentation. I hope what I have shared will be beneficial for all of us. That is all from me. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh.